Hello everyone. Let's start our homework 7. So it's about Laplace transform.
I can't
And
hear you.
hello, hello. Can anybody hear me? Okay. I think you can hear me, I guess. Hi, buddy. I think other people can hear me, but I think it's in your some problem is in your headset or something. Other people are saying they can hear me. Buddy, can you hear me now? Okay, probably he has some bad connection. Okay, it will be recorded, so he will be uh, here next time from the video. So I think you probably know that solution of homework 7 is already posted in the island actually. So solution is actually already posted. You can see, but I will try to explain a little bit more than this homework solution manual. So the first problem says that using the pole zero plot, that means from this transfer function, you know that ASS is a transfer function, and the numerator, from the numerator you can find out what is the zero, and from the denominator you can find out what is the pole. From this pole zero plot, explain why this transfer function with region of this. I mean, this is not very important. This is just saying that, okay, it is causal system. I mean, just like this kind of function, like real part of s is greater than real part of alpha. So it is just saying that thing, that s minus minus 10. If you compare with this equation, s minus alpha, this alpha is here, what alpha is here minus 10. That's why real part of s is greater than minus 10. So it is just saying the general causal system. Its answer can be look like this way. So we don't need to actually think about this for explaining. I mean, we only need to, it's only verifying that it's a causal system, it's fine. Now we can just plot the pole zero and decide why it is a high pass filter. So at first, let's look at the what is the pole and what is the zero. So for Laplace transform part 2, you have already seen that transfer function can be written as this kind of small part multiplied, like s minus something multiplied by another s minus something. So from this numerator part, you can find out the zeros is z1 and z2. And from the denominator, you can say that its pole is p1, p2, and p3. So that means you always need to write it in this form, s minus something. So here only s. That means it's actually s minus 0. And s plus 10, that means s minus minus 10. So if we write it, it will look like s minus 0 and s minus minus 10. So I was saying that the numerator, from the numerator portion you find out the zeros, that is your j dot z done, whatever you say, and from the denominator you can find out your pole. So it is p or say p on. So 0 is actually 0 here. So if you draw it in the S-plane, then this zero term is here, 0 is here, and pole is -10. So we generally represent pole as this kind of cross sign and 0 as this kind of circle. So this is your pole 0 plot. This in the S-plane, this is the j omega line. So what is it saying? The question was, explain why it is a high pass filter. So let's draw what is high pass filter actually. High pass filter is, if you draw it in actual frequency domain, say it is f, or say this axis is omega, f is in hertz, you know that the unit of frequency is hertz, and in omega or angular frequency domain, its unit is radian, radian per second. So how the high pass filter looks like? High pass filters looks like high pass. That means it only passes high frequency. Similarly, low pass, that means it only passes low frequency. Band pass, that means it only passes a region of frequency. It does not pass very low frequency, it does not pass very high frequency. It only passes a narrow range of frequency. Similarly, band reject filter, that means it does not allow a narrow range of band of frequency. So let's draw the high pass filter. So high pass filter is, it does not pass any low frequency. Here frequency is low, it's only higher than 0, 0, 1, 10, it's gradually increasing. When the frequency is high, then it can pass. Then it has some amplitude. So this axis is actually amplitude of your transfer function. Say A is j omega. This is your what is it called, transfer function. If you take the amplitude, this axis is showing the amplitude of your transfer function. Here it has some value. This transfer function in the high frequency region, it has some value. But in the low frequency region, it does not have any value, it's 0. It's nothing. That means it does not pass any low frequency, it only passes the high frequency. That's why we call it high pass filter, say ASP, high pass filter. So from your this transfer function, which is given in your question, you need to verify that yes, this transfer function from this pole 0 plot, this actually behaves like this way. So what we will do, we will check when this f, or say omega, this is the omega, when this omega is very small, say here, when omega is around almost 0 or very small, then what happens to this transfer function, I mean this transfer function, and when omega is in this region, so much higher, then what happens to this transfer function. So from the pole 0 plot, what your class lecturer was saying, you can, when you take this magnitude of hj omega, what you need to do, at first plot all the pole and 0, then select any j omega here and draw a line. So here, take any point in the j omega line, then draw a line here. This is a straight line actually. And then actually compare if this point is here, if this point is very high, or if this point is very low, very high or very low, that kind of stuff. So if this frequency is very low, you know that why I'm saying why it is frequency is very low. This is the j omega axis, right? This is the j omega axis. So when it is like here, that means omega is very high. When it is only near zero, like here, that means omega is very small. So let's at first draw this line one more time when omega is very small. Let's draw that, where we can draw, say drawing here. So where was our pole and zero? Zero was here, pole is here. So if omega is very small, say your target is here, this is say small frequency. Then if you draw the line, if you connect the zero, this line is very small. But if you connect the pole, this line is much larger. I mean, the if you come more closer to zero, you'll see that this line make it like red line. Then it's better to understand. So say this red line will be much shorter than the blue line if omega is very small. Omega is very small means in this region, I am saying omega is very small in this region. So in that region, what is happening? From this graph, blue line is very large compared to the red line. So what will happen? I'm looking for where it was. Okay, here it is mentioned. So what it becomes, whether this transfer function hj omega is very small, so 0, or almost infinity. We will try to compare this kind of relation. So now look at these equations and these equations. So this blue line is actually here, and this red line is actually in the numerator, right? This red line is from the zeros, and this blue line is from the pole. It is here. So you can say that I was saying this line, this red line for the zero is small, and this one is very large. So if you divide a very small thing with a large thing, what will happen? It will eventually become almost around 0, right? Say small is 1, large is 1000, then it will become almost 0. So when it is happening this thing, when j omega is very small, this is the region when omega is very small, then your transfer function is becoming what? Becoming 0. So now we can decide, yes, it's actual, at least it's not low pass filter, but still we don't know whether it is high pass or band pass, or yeah, whether it is high pass or band pass. For that, you need to take a very high omega, very large frequency. Then what will happen? Yeah, buddy, can you hear me?
Yeah, can you explain again how we know that when the omega tends to zero, that it's not a low pass filter?
Oh, okay, maybe I should draw the low pass filter actually. So professor was showing when he was drawing in the class lecture, if you remember, he was actually showing both the negative frequency and the positive frequency. But in the most of the, if it is not a signal course, you will see that we generally do not draw negative frequency, we only draw the positive frequency. So now I'm actually drawing only positive frequency. Like here, I was showing only positive frequency. That's not your question's answer. I am just saying something else. So if you compare it with professor's lecture, he was drawing another part for the negative frequency. But for your calculation, actually, you don't need to consider this negative part. So that's not your question's answer. So now I'm trying to give your question's answer. So this is the low pass filter. So low pass filter means for very small frequencies around zero, its value is high. Say its value is one or some value. But when frequency is very large, it becomes zero. That's the low pass filter. But your question is not for low pass filter. Your question already says that that transfer function is actually high pass filter. Verify that thing. So even if the question was for verify it is a low pass filter, approach is same. At first, you need to give a very small frequency, and check what happens to this transfer function. So the trick what professor is showing in the class lecture is from this kind of diagram. What is the length? What is the length of this blue line, which is coming from this pole, or actually the product of the blue line? If you look carefully here, it is actually, where is that thing? Yeah, it is the product of this either all the poles length and all the zeros length. You have to take the product and then compare. And for easier, this question is kind of little bit easier because there is only on zero, only on zero, and only on pole. So you are not multiplying anything. So zero was drawn here. This is your zero. You take any omega, say small omega here, draw a line, which is the red line here, which is this red line here. And for the pole, you draw another line, which is the blue line here. So when omega is very small, you can see that this red line is very small here. And this blue line, it is very large. So if you divide a small thing by a large thing, it becomes almost zero. This is here. This is the zero. That's why I am understanding it may be high pass filter. At least it is not a low pass filter, because at that moment it should have some value, but here it is zero.
Oh,
Ha-
okay. Okay. I see what you're saying.
yeah,
It the frequency when you divide it. Oh, it should okay. All right.
yeah,
It should have a value and not be zero.
yeah,
Okay.
right, yeah. And still we don't know whether it is high pass or band pass, because band pass also look kind of similar. Sorry, at the beginning it's also zero, then it becomes something, again it becomes zero. That's the band pass filter. This is the BP. It's a band pass filter. So still we don't know whether it is high pass or band pass. For that, we need to take a very high frequency and check whether it has some value, say 1 or something, or it is zero. Like if it is zero, then we may assume that it's a band pass filter. But if it is something, then something or so on, we will say it is high pass filter. So let's check. So that means you need to take a very high frequency. There's a lot of mess. Where can I draw? Let's remove something at least. Okay, so I am drawing this pole zero plot one more time when frequency is very high. So this was your zero, is at zero, and this is your pole. When frequency is very high, say in this point, then if you draw the line, so this is say your zeros line, and this is say your poles line. Draw it in a different color. So this is red line, and this is the blue line, like the similar one. So you can see that if this frequency is very high, what will happen? This red line and blue line will become almost same, right? If it is, I mean, if this part is very long, then this small distance does not matter. It will become almost same. Their length will become almost same. So that means from this transfer function, if you divide this part and divide by this part, they are almost same in length. So if their length is same, then if you divide, what will happen? Its answer will become around 1, almost approximately equal to 1. I mean, at least it's not 0. That's your target actually. I mean, if it has some value, then you can say it's a high pass filter. So you can say that when it is very high frequency, the length becomes almost equal. So it's, if you divide, it will become almost around 1. So that's why it's a high pass filter. It's a high pass filter. Okay. Okay. Next, let's move on to next question. The problem 2 and 3 is kind of, yeah, buddy. Hello.
Yeah. So do we, when we're drawing this, would it be necessary to also include like that line for the ROC? Is it necessary to include the line for the ROC in the picture?
No, no, no. It's not necessary here.
Uh,
I mean, not for this question. Okay, so let's move on to problem 2 and 3. Problem 2 and 3 is kind of same. So what is our target? Differential equation is given. You need to find out the transfer function AST. What is AST? AST is output divided by input. That means YT by XT. That's called your transfer function. So you have to do it in Laplace transform domain. So if you convert this YT into Laplace domain, you become YS. XT becomes XS. Dy by dt become S times YS. If it is a double derivative, it becomes S square YS. So let's say that. So what I'm saying, if it is a Y, it becomes YS. If it is a derivative, then you write the same thing because it is a Y, so you write YS. But for first derivative, you write SYS. If it is a second derivative, say if it is d square y by dt square, what we write? This is y, so we write ys. It is second derivative, that's why we write s square ys. This is xt, that means x, it is xs, and this one is kind of a little bit problematic. We know this is xt, so it must be xs, but there is a time shifting. For time shifting, you have to do something. You have to multiply with something here. So what you have to multiply? That is actually in your class lecture somewhere. In lecture 6. I'm looking at lecture 6 actually, not lecture 7. Yeah, here it is. So if it is shifted in time domain by t naught minus t naught, then you have to multiply in the Laplace domain with e to the power minus s t naught. I mean, whatever here it is, if it is minus t naught, it will be minus s t naught here. If it is plus t naught, it will be plus s t naught here. So what is here? Here it is minus 1. So that means you have to multiply with minus s, right? It will be minus s because t naught is on. So it will be e to the power minus s. So that means for this part, you have to multiply with e to the power minus s. Okay, let's check whether I'm doing it right or not. Okay, for the previous question, if you look at everything, I think you might see this part a little bit different. What is doing it here? Instead of writing s, and for problem 1, instead of writing s, write it j omega. This is j omega. And now if you take the magnitude s, then it is j omega If you take the magnitude, j vanishes because j is imaginary. You don't need to write the j. And in the denominator, j omega plus 10, this is the j omega plus 10. If you take the magnitude, what you have to do, you have to write it in a square plus b square, then root over form. That's why 10 becomes 100 and omega, j omega becomes omega square. So I was talking about the problem 3. Yes, it is e to the power minus s. Okay, let's try to solve one of the problem. Yt, I mean, the first conversion is done. You can do everything. Yt, ys, d square y by dt square, that becomes s square ys. And I have, now you can understand everything, what you have to do. Dx by dt becomes s times x ss. I mean, it is x s that you have to multiply with a s because of this derivative. And this part was only complicated, and I was saying that you have to do multiply with e to the power minus s here. So now everything is in Laplace domain. For problem 2 and problem 3, you can write it in Laplace domain. Now, after writing the equations, you have to find out the answer. So for problem 2, it says to find the transfer function, ht. So that means after writing everything in S domain, you have to take all the y and all the x in left hand side and all other part in the right hand side to find the answer. So how it looks like, I think I can directly show you the how it is done here. So the question was this first line, yt becomes ys, xt become xs, and d square y by dt square become, this is double derivative, that's why s square. Now what you have to do, you have to write, say, you can easily find out what is ys by xs. I mean, if you a little bit confused what it was, I need to just show on equation, then we will figure out what is for other part. Ys is equal to s square ys xs. So the next line will be ys multiplied by 1 plus s square, which is equal to xs, right? Yes. So after that, if you take ys divided by xs, it becomes 1 by 1 plus s square. Just normal mathematics. So this is 1 by 1 plus s square. So now what you can do, you can do it in a hard way, or you can use some tricks here. Here is some tricks. So if you try to do it in hard way, what I mean, you are doing this kind of partial fraction expansion. So you can do that, like there was an example for s square plus 1. So what they are doing, they make it in s minus j, s plus j, make partial fraction expansion. After doing everything, you find out it is something e to the power j something, then converting it to sine form. This is one way, this is the way, but from the solution, what it is suggesting actually, it is actually kind of, if you search in the Google, say Laplace transform, Laplace transform, and if you go to the image, you will see there is a bunch of equations. So I have downloaded first 2 or 3 equations. I mean, this kind of picture. One of the picture looks like this. If it is a sine function, so sine bt, if you take the Laplace transforms, it becomes this way. This b is at the top. It is also at the denominator as a b square. Yeah, you can do the shortcutting the finally, yeah, of course, yeah. Only you need to write down this equation that say like this way, like here it is written sine omega t or say sine bt, like that is picture. If you take the Laplace transform, you can get this answer. And if it is a cos omega t, then what will happen? This is also written here. If it is a cos bt, instead of b at the numerator, you have to write s at the numerator. That's the difference. So if you, after writing these equations, now you can compare with this equation and this equation. What you see, omega naught is on. This omega naught square is here on. So now you can directly write the answer that from these h's, you can write it in time domain in ht. What will be the answer? This sine omega naught. This sine, what was the omega naught? Again, omega naught was 1. That is why I'm not writing anything here. Instead of writing sine omega naught, I am writing sine 1 into t. That is sine t, right? 1 into t. And everything is causal LTI system. That's why this is causal system actually. That's why you need to write ut, multiplied with ut. Like your all of the your example, there was some multiplication of ut. Why is your sine omega t? I mean, do you want to choose something else like cos or something? Yeah, so you cannot choose cos because if it is a cos omega t, then this omega naught, what it should be s. If in the numerator it is s, then it becomes cos omega t. Like in this picture, you can see from cos bt, if you take the Laplace transform, in the numerator it is s. Okay. So, and so that gives the answer of the problem 2a. Next, move on to problem 2b. Problem 2b was these equations. You take the Laplace transform, y becomes ys, 2s ys, s square ys, and s xs. That is written here in the Laplace domain. After that, you, like this previous question, take some mathematics, do some mathematics, and find out what is ys by xs. Why we always do that? Because we need the transfer function. Your question says, what is the ht transfer function in the time domain? Here, so far you have find out what is the transfer function in the s domain or Laplace domain. Then we will find out what is in the time domain. So, okay, so you have got these equations, and s square, this is like a minus b whole square format. So you write it in a minus b whole square. And you probably already know from the partial fraction expansion equation that when there is this kind of square term, when you do partial fraction expansion, one will be without square and another will be with square. Like some example here. Yeah, like here, if there in the numerator, denominator, if it is a square term, you have to write 1 without square, 1 with square, and a b. Then after cross multiplication, you need to check what you have to check, all the coefficient of s with coefficient of s here. Like here, as is equal to s. Next line, a equal to 1. Similarly, all the constant coefficient. Here constant coefficient is b and also a plus b. a plus b, a plus b is equal to constant here, a plus b equal to minus 3. a plus b equal to minus 3, next line, b equal to minus 4, because you already know the a value of a. So you have to do the same thing here. You have to do partial fraction expansion. After you do that, you will find out this a and b both will become 1 actually. And there is a line missing. You have to do it by yourself. By doing partial fraction expansion, you will find out a and b is both 1. Okay, now we try to solve this, convert this form in time domain. There is something written I don't like in this format because it does not, it is written correct way, but from the example what you are actually learned so far, it does not matches with that thing. What you have learned at the very basic example, I always go back here. If it is 1 minus s minus alpha, this format, you know the answer, e to the power alpha t ut. So if this alpha is 1, what will happen? E to the power t, alpha is 1, e to the power t ut. So your this part 1 by s minus 1 is exactly similar to this one, 1 by s minus alpha. So you know the answer. It will be e to the power t ut. So its answer will be e to the power t ut. If you multiply with this one, the first one part will be e to the power t ut. There is another part. That's why there is a plus sign here. The another part is from here, s minus 1 whole square. So at first you write down this one is will be also e to the power t ut, like here it is written e to the power t ut. That will give only 1 by s minus 1, but it will not give you square. To get this square, you need another property. This is also in lecture 6. You don't have to remember all of these equations. Most of the time the property what we use is this time shifting property. This shifting in the s domain, shifting in the time domain, shifting in the time frequency domain. This 8 and 10, and sometimes this convolution also 8, 10, 11. This one, of course. Why do we use this? The first line, or when we do these equations, y becomes ys, differentiation become sys. That property is coming from here, there. And also this form that I need from right now. If you multiply with time domain, with t, in the s domain, you have to take derivative and also multiply with a minus sign. So same thing here. If you take the derivative of 1 by s minus 1, what will happen? It is kind of 1 by x form. If it is kind of 1 by x format. If you take the derivative, what will happen? It becomes 1 by x square. So here it is also like that way. If you take the derivative, it becomes 1 by s minus 1 whole square. There is a minus sign, of course, but here there is another minus sign. That makes this minus plus. Now life is easier actually. So like if you take this, take differentiation and multiply with a minus sign, you get this one. And from the property, we know what you have to do in the time domain. You only need to multiply with the time t, then it's done. So same thing. This part actually give you the only e to the power t ut, but to get the square, you only need to multiply with a t, then you are done. So answer of this part is e to the power t multiplied with t ut, and answer of this part is only e to the power t ut. Then you add up. That is written here. This is written here. If I write it one more time here, like what is written there from the first part, so when it was 1 by s minus 1, it is giving you e to the power t ut, and there was a plus sign, 1 by s minus 1 whole square. That part is giving you also e to the power t ut, but you have to multiply with a t. This is your ast in the time domain. After that, if you take the common part, then you can write it also in this form. Common part is e to the power t ut. Any question? Okay, if not, let's move on to problem C. It is also, I mean, all the question is kind of similar, only when you convert your HS to HT, at that moment you have to use different property. That's the difference between A, B, C and problem 3. So from problem C, same thing, 25ys minus 6sys s square ys is equal to xs minus s times xs. So that is written here in the Laplace domain. Then find out the transfer function. Now here you can do it in hard way also, like there was an example at the very end, like this kind of stuff. You have to do a lot of complication, or you can use some property. So what is the property we are trying to use here? At first, try to write this s square minus 6s in terms of a minus b whole square format. So if you write it in a minus b whole square, what is that? S square minus 2 times 6 is actually 2 into 3, right? 2 into 3, 2ab form. A square minus 2ab plus b square. That will give you a minus b whole square. Okay, let's me write that thing. S square minus 6s plus 25. A square minus 6s plus 25. Let me check. S square, yeah, right. So after that, what we want to do, we want to write it in a minus b, kind of this form, a square minus 2ab plus b square, which is equal to a minus b whole square. We need to write it in that form. So s square minus 2 into 3 into s plus 3 square. But there is 25 and you have here 9. So you need something more. That is 16 here, right? So that is s minus 3 whole square plus 16 can be written as 4 square form. So that is everything here, s minus 3 square plus 4 square. Then we do one more thing here. At the numerator 1 minus s, write match these two things. In the denominator you have something like a square plus b square form, or say no, I mean like s square plus b square form. In the numerator you make these two parts same. If you try to make these two parts same, then you need something more. It was 1 minus s, but you need s minus 3. It was 1 minus s, but you need s minus 3. Then what you have to do? You have to write a minus sign here, and there it becomes plus 3, but you had only 1. So you need one more thing, plus 2. That is written here actually. This is minus s minus 3. Okay, there is that a minus 2 or plus 2? Okay, that was plus, that should be minus 2 actually. I made a mistake here. So that is minus 2 to make it equal. So that is written here, minus s minus 3, and another part is minus 2. And the denominator is same in the both cases. So what is the benefit of doing all this? If you write it in this form, you can compare with COS format. COS format has this one, if I go back to speak that picture again, if it is a sine at the top in the numerator, it will be b, this b, denominator same b square. If it is a cos, in the numerator it is s, in the denominator it is b square. So that's why we are trying to write everything in something s square plus b square. Like here, s square plus b square, b is 4, s square plus 4 square. So in both cases, see, this is s square plus b square, this is s square plus b square. Here this 4, you have to write same 4 here to make it look like sine. Because if you look at this equation, you see this b and this b is same. To do that, there was 2, but it was not 4. That's why we are taking another extra part, multiply with half and make it forcefully 4. Now it is actually exactly similar to sine form. Like here, this 4 by s square plus 4 square, that is actually sine bt, this b is 4, sine bt ut. I mean, we still have not considered this minus 3. We are considering this is just s square, assuming it is just s square. Similarly here, we are not assuming it is s minus 3. We are assuming that it is just s. This is s by s square plus 4 square. We are writing here s by s square plus 4 square. It is the cos format, right? It is the cos format. So this part is giving you cos, this part is giving you sine, but there is something more. There was 3 actually, minus 3, that we are not considering at the beginning. S is shifted by 3 unit. If S is shifted in the S domain in some by something, then what happens in the time domain? I was saying there are some property you have to always look for. This is one of the property. Shifting in the time domain or shifting in the frequency domain. So what is that? Here it is shifting in the S domain. Here it is shifting in the S domain. S is shifted by S naught. Then in the time domain, you have to multiply with e to the power t, multiply with whatever is the shift. If this shift is 3, s minus 3, then it is e to the power 3t. Same thing here. Here it is s minus 3. So that's why you have to multiply with e to the power 3t. So from this part, when it is s minus 3, then instead of writing only cos, you have to write cos with e to the power 3t. When it is this part, there s is shifted by 3. So it is originally it was sine, only sine, but due to this shifting of 3, you have to multiply with e to the power 3t. So now your answer is done. This part is written here. This sign format is written here. And there was something else. There was a minus sign. That minus sign is coming here. There was a minus half. That minus half is coming here. Okay, any question? Okay, if not, then let's move on to the last problem, problem 3. Problem 3 is also similar. I was saying always remember that shifting in the time domain, shifting in the frequency domain, convolution, and what else was? I forgot again. Yeah, shifting in the or differentiation. Or okay, shifting in the time domain, S domain, differentiation in the time domain, S domain, and convolution. This 5 property is needed actually in most of the cases. So problem 3 is same. Only difference is here xt is actually has some value. Xt is ut. So at first we can write yt is ys, Laplace domain similar to problem 2. This one is sys, s times xs. And this one is also, oh, sorry, this is not s times x, this is only xs, because this is not differentiation, only x. This is also xs, but due to this shifting in the time domain, give you, this is the shifting in the time domain, you have to multiply e to the power minus s with this shifting value in the s domain. So that's why it is e to the power minus s here. So it should look like actually xs minus e to the power minus s xs. But why they are writing 1 by s? Because xt has some value. Okay, let me write down that equation. So initially we should try to write it in ys plus sys is equal to xs minus xs multiplied with, because of this time shifting, you need to write e to the power s t naught. This was your t naught, right? This is s t naught, but your t naught is only 1. That's why we are writing only s. We don't need to write s into 1. But xt is ut. So if it is xt is ut, then you can write, instead of writing xs, you can write 1 by s. Why? Why is that? Negative s? Oh, really? Oh, negative s? I have not. Let me check. Oh, yeah, right. Negative s. Yeah, you are right. So let's compare with that equation one more time. Yeah, if it is a minus t naught, it becomes minus s t naught, right? So in your problem, this is minus t naught. So you need minus s t naught here. You are saying that this thing. I made a little mistake here. Okay. So I was saying when this is xt, you have to write it on by s. Why? It is easy. It is just your first very easy problem. First example. Yeah, this one. If it is ut, multiply it with 1, or e to the power 1 is what? 1 is e to the power 0 into t. Alpha is 0. If alpha is 0, it is nothing but only ut. Then put here alpha equal to 0. If alpha is 0, what is that? 1 by s. That means if it is ut or alpha is 0, that give you only 1 by s. That we are writing here. This is only 1 by s. From the xs, you get this thing. So after that, you can write down, okay, what we need to do? We need to solve for yt. We don't need to do find transfer function here. We don't need to find ht here. We need to find solve yt. So there is only y here. There is no x. So you actually cannot do transfer function here. After that, you need to find out what is the ys. So if you do that, it will look like this equation. After that, we are trying to split it in two parts. One part like this 1 is here, minus e to the power minus s is here. Trying to simplify. We always try to simplify in a format what we already know. We know actually we only know 3 equations actually, we would say. We only know 2 or 3 equations. Say this equation, or say the next equation, and these two equations, sine bt and cos bt. We only know this kind of 4 equations and some property, of course, some 5 property. So we have to always try to match with this kind of format. Either it is a square plus b square, s square plus b square format, or it should be in the 1 by s minus something format. So we are also trying to do this here. This is s times something. We need to try to make it in that kind of format. This is s minus 0. This is s minus minus 1 format. So what is these two lines here? This is that partial fraction expansion, nothing else. So partial fraction expansion, what is that line actually? 1 by s into s plus 1, you can write it in as a by s plus b by s plus 1 format. And this is s is actually s minus 0, right? So after that, you find out what is a and b, and that is giving here every a and a is 1, b is minus 1. That's here you are getting here. From this part, it is also the same, right? This is 1 by s by 1 by s into 1 plus s. Here it is also, though there is e to the power minus s multiplied, you can take it outside. Then this part and this part is both are same. Now you convert this to time domain format to get the yt. So 1 by s plus 1, it becomes this one, like this. Very easy example, like this one. I don't want to talk again. You already understand that thing, I know. And when it is 1 by s, it is only ut, right? I mean, that means ut, here alpha is 0. Here alpha is 0. So 1 by s becomes only ut. This 1 by s is becoming only ut. This is 1 by s minus 1 is becoming e to the power alpha t ut here. This part is also same. I mean, this part and this part is actually same, but there was e to the power minus s. That's why from this equation, you have to shift it by 1. Why? If you go back again to that property of the 5 property, one of the property is shifting in the time domain. I was saying 5 property, shifting in time domain, s domain, differentiation is s domain, time domain, and convolution. So this is the shifting in the time domain, give you e to the power minus s t naught or minus s something. So here you have e to the power minus s. That means its t naught is 1, right? E to the power minus s t naught. T naught is 1. So you have to write, instead of writing xt, you have to write x t minus 1. T naught is 1. X t minus 1. You are writing it this thing actually. ut becomes ut minus 1. E to the power minus t becomes e to the power minus t minus 1. Ut becomes ut minus 1. Okay, that's it. Okay, any question? Okay, if not, then thank you and good luck for your final exams. Okay, bye.
Yeah, man. Thanks a lot, man. You're excellent TA, bro. Appreciate it. Learned
Thank
a lot.
you. Thank you.
Have a good day, man.
Okay.
Hey, I have a
Same to
question.
you. Yeah.
Do you work with Dr. Shalin? Right?
I mean, my PhD research.
Yeah.
Oh no, I am with Roger Lake actually.
Are you doing signals and systems too, or something else?
Something else actually. I am in device, nano device.
Oh, cool.
Yeah,
Very cool.
electronics.
All right, man. Have a good day.
Okay, thank you. Okay. Good luck to everyone. Bye.